Okay guys, let's have a look at the last page then, page 20. That's question 14. We've got this diagram here. In the diagram below, AD is an arc of a circle. So there's a circle there. This is the center O, and this arc of circle. And OCB is a triangle. So OCB is a triangle. You're given that DOA, so this angle here is 135 degrees. O to D is 5.3. Right, okay. And then C to D is 8.2, so this distance here is 8.2. And A to B is 18.8. And then we need to calculate the area of the shaded region AB, C, and D. There's shaded region here, yeah? Okay, so if this is an arc of a circle and that's 5.3, that would be the radius, so this would be 5.3 as well. So that would make this whole side then, so I'm just going to add up this 18.8 plus 5.3, so let's put it in the diagram while we're at it, yeah, before we start thinking about the problem. 18.8 plus 5.3, and we get 24.1. Okay, so that's 24.1. By the same token, we do this exactly the same thing here for this length. It'll be 8.2 plus the 5.3, so let's just tap that in and get that length, times 5.3, you get that, 43.46 times, cancel, it's 8.2 plus 5.3, isn't it, equals, and you get that, 13.5. So let's put that in then. So we got that length and that length. Remember the formula for the area of the whole triangle, right? Because the area of this shaded region will be the area of the whole triangle, won't it? And then cut off or take away the area of this little sector here. So area of OCB, so that's the first thing we're going to work out. Now the formula is half AB sine C. Half 1 AB, these sides like this with the angle in between. It's half AB sine C, so it's half of this, 13.5, times this length, 24.1, times the sine of the angle in between, 35 degrees. Tap that in the calculator. Now that comes from the inside cover in the exam paper, doesn't it? The area of the triangle is given by that formula, half AB sine C. And that's, in regard to this triangle, these are the two sides in the included angle. Okay, so let's tap that in the calculator. So it's 0.5 is half, so we can write that, times 13.5, times the C, which was 24.1, times sine of 135, and I'm in degrees mode, so I can just tap that in, 135 degrees equals, let's see what we get, 115.03. See, the 8 rounds a 2 up to a 3, so I'm going to do that, 115.03. 115.03. Okay, and it's centimeters, so this would be centimeters squared. That's the area of this whole triangle then. Great. Now we need to work out the area of this sector of a circle. The area of a circle, of an entire circle, we know is pi r squared. And that's when it goes around 360 degrees. So the sector of the circle, the portion of the circle we've got, or the fraction, is 135 parts of 360, haven't we? So it's that fraction of the whole circle. So area of sector will be, well, it's 135 parts of 360. It's how much we've got, haven't we, of this circle? That's the proportion, the fraction. Fraction of the circle, pi r squared. Fraction of the whole circle, pi r squared. The radius is 5.3. Now we can use pi in the calculator or 3.14. This time I'm going to use the pi in the calculator because we're allowed to do that. So we've got a fraction, we've got 135, then we've got 360, Okay, that's our fraction back to ground level times pi, wasn't it? So shift pi times, and then it was 5.3 squared, the radius squared. And then we can square it. 135, that fraction of the circle, the area of the circle is pi r squared. So it's that fraction of the circle. Equals 33.09 to 2dp. Yeah, so we get 33.09 to 2dp. So then the shaded region then will be the difference, won't it? We cut away the sector from the triangle. So area of shaded region, the shaded region equals this area of the whole triangle, 115.03. Take away the sector, so you cut that away from it and you get the area of the shaded sector. So it's 115.03, take away 33.09. 115.03, take away 33.09. Yeah? Equals 81.94. So let's round that to the nearest centimetre. 81.94 centimetres squared to 2dp and equals 82 centimetres squared approximately. Okay, that's it. That's the that's page 20 done, and that is the last question on the paper. So good. So that completes this paper then, this section, and great. So I'll see you in another video somewhere, sometime. Cheers.